Pause for just a second and imagine this. You have an identical twin, someone exactly like you in every way. Now, imagine putting your twin on a spaceship traveling close to the speed of light, heading toward the nearest star. You stay on Earth, watching the years pass by, as calendars flip like falling leaves. And then, the big day arrives, your twin returns. But wait, something's off. The person stepping off the spaceship hasn't aged as you expected. While you're now in the twilight of your life, perhaps walking with a cane, your twin looks as if only a few years have gone by, still full of energy. No, this isn't the plot of a sci-fi movie. This is one of the most mind-bending yet fundamental truths of our universe, revealed to us by Albert Einstein. But how can this be? How can time slow down for one sibling, while racing ahead for the other? In this video, we'll peel back the layers of the most famous thought experiment in physics, the twin paradox, step by step, in a way anyone can understand. Get ready to have your perception of time turned upside down. Does time flow the same for everyone? Most of us think of time as something absolute, like a river that flows steadily for everyone, everywhere. Whether you're in New York, Tokyo, or floating in space, we assume the tick-tock of a clock sounds the same. For centuries, Newtonian physics backed up this intuition with the idea of absolute time. But in the early 20th century, a young patent clerk named Albert Einstein shattered this belief with a revolutionary idea. In 1905, he published his special theory of relativity, in which he declared that time isn't fixed at all. In fact, it's flexible and relative. One of the theory's most groundbreaking ideas is this: the speed of light is constant, no matter who's measuring it or how fast they're moving. This seemingly simple idea unlocked an extraordinary realization: if the speed of light is fixed, then something else, like space and time, must change. Einstein proved mathematically that as an object moves faster, time slows down for it. This phenomenon is known as time dilation. Put simply, the faster you move, the slower time flows for you. As strange as it sounds, this is not just an abstract formula. Let's visualize it using a classic analogy, the light clock. The light clock analogy. To understand how time slows down, let's build the simplest clock in the universe. This clock has two parallel mirrors and a single light particle, a photon, bouncing between them. Every time the photon hits the top mirror, we hear a tick, and every time it hits the bottom one, we hear a tock. Tick-tock, tick-tock. The rhythm of this clock depends on the distance between the mirrors and the constant speed of light. Now, let's place this light clock inside a high-speed spaceship. From Earth, we observe the clock while the spaceship is flying by. When the ship is stationary, the photon moves straight up and down. But as the spaceship speeds sideways, the photon now has to travel a diagonal, zigzag path to reach the mirrors. Here's the key: the speed of light must remain constant, both for the astronaut on the ship and the observer on Earth. So if the light now travels a longer, diagonal path, due to the ship's motion, but its speed can't change, then there's only one possible outcome: it takes more time to complete each tick-tock. From Earth's point of view, the moving clock runs slower. And it's not just the clock. Everything on the ship, biological processes, chemical reactions, even thoughts, is happening more slowly. For the astronaut, time itself is flowing more slowly compared to people on Earth. The story of the twins. Now let's return to our main characters, Ayşe and Fatma, two identical twin sisters, both 30 years old and full of life. Ayşe chooses to stay on Earth and live a quiet life, while adventurous Fatma is selected for a historic mission, to travel near the speed of light to a nearby star system and return. Fatma boards the spacecraft and disappears into the cosmos. Inside the ship, everything feels normal to her. Her clock ticks, her body ages, her days pass just as they do on Earth. After 9 years aboard, according to her clock, she completes her mission and returns home. As the landing capsule opens, Fatma steps out, still 39 years old and looking almost the same. But among the crowd waiting for her, she spots her sister, and is stunned. Ayşe is now 94 years old. Her hair has turned white, her face is wrinkled, and her body has aged. Because while just 9 years passed for Fatma, 64 years passed on Earth. Fatma has leapt 55 years into the future. Think about that for a second. For one sister, it was just a long trip. For the other, it was an entire lifetime. Time dilation is no longer just a thought experiment, it has become a tragic and beautiful reality. The paradox appears. At this point, a clever question might pop into your mind. Wait a minute. Didn't Einstein say motion is relative? Then from Fatma's perspective, isn't Ayşe the one who moved away and came back? Shouldn't Ayşe be the younger one? Exactly, this is the heart of what we call the twin paradox. If each twin sees the other as the one in motion, how can we say for sure which one has aged less? This might seem like a paradox, an unsolvable contradiction. But don't worry. It's not actually a real paradox. The confusion comes from everyday intuition. The solution is logical and surprisingly simple, once you understand the key. Ready for the big aha moment? The twist that solves it all: acceleration. The answer lies in a single word: acceleration. Ice and Fatma situations are not symmetrical. They never were. Ice stays on Earth the entire time, in what physicists call an inertial reference frame, a system moving at a constant velocity, essentially not accelerating. But Fatma's journey is full of dramatic acceleration. She accelerates to near light speed at launch. She decelerates, slows down, to stop at the destination. She accelerates again to return to Earth. She decelerates one final time to land. These moments of acceleration break the symmetry between the two sisters. Only Fatma changes her frame of reference. Only Fatma feels the force of acceleration. That's the key difference. Special relativity applies to objects in uniform motion, but once you introduce acceleration, the math changes, and so does the story. The most dramatic shift happens during the turnaround point. At that moment, Fatma's now suddenly jumps forward on Earth's timeline. From her perspective, Earth and ice rapidly ages during the turnaround. That's when the years fly by for ice. So, the twin paradox is not a contradiction at all. It's the logical outcome of an asymmetrical journey, where one twin remains in an inertial frame, and the other undergoes acceleration, deceleration, and a change of direction. The twin who experiences acceleration is the one who ages less. Real-world proof. You might be thinking, okay, great theory, but is there any proof? Absolutely. Time dilation isn't just theoretical, it's been tested and proven repeatedly. In 1971, physicists conducted the Haffel-Keating experiment. They flew highly accurate atomic clocks on commercial airplanes around the Earth. When compared to identical clocks left on the ground, the airborne clocks had lost time, exactly as Einstein predicted. A more modern example: NASA's twin study. Astronaut Scott Kelly spent nearly a year aboard the International Space Station, while his identical twin Mark Kelly stayed on Earth. When Scott returned, scientists found measurable differences, including slight changes in age and biological processes. Even your smartphone provides daily proof: the GPS system. Satellites orbiting Earth move at high speeds and are farther from Earth's gravity. Both special and general relativity affect how time flows on those satellites. If engineers didn't constantly adjust the onboard clocks using Einstein's formulas, your GPS location could be off by kilometers every single day. If mind-bending science topics like the twin paradox fascinate you, make sure to subscribe to the channel and hit the notification bell so you don't miss future videos. And share this video with a curious friend. It's one of the best ways to spread the wonder of science. Now, I want to hear from you in the comments. If you had the chance to time travel, would you visit the future like Fatma or the past?